Hi, in this video, we are going to learn to use our form that we learned in the previous video to solve an equation. So let's look at example 12. We will have this 2 cos theta plus 3 sin theta, and we have to express it in the our form, and then we have to solve it equals to 1. Let's start with expressing it into our form first. We have 2 cos theta plus 3 sin theta equals to r cos theta minus alpha. So by compound angle, we have r cos theta cos alpha plus r sin theta sin alpha. So the next step is by comparing. We will have 2 is equals to r cos alpha, which is our equation 1, and 3 is equals to r sin alpha, which is equation 2. So when you have equation 2 divide with equation 1, you will get 3 over 2 is equals to r sin alpha divided by r cos alpha. So the reason that we divide 2 with 1 is so that we will get tangent alpha is equals to 3 over 2. So we find the angle alpha, which is tangent inverse of 3 over 2 is 0.983 radian. So why do I get this in radian? It's because of the question. It says acute angle in radian. The next one I'm going to do is to find the value of r. So we will have the equation just now. 1 square plus 2 square, we will get r square cos square alpha plus r square sin square alpha is equals to 2 square plus 3 square. So if I simplify them, this is going to be r square and cos square alpha plus sin squared alpha in the bracket equals to 13. So r square is equals to 13. R is equals to square root 13 because r is positive. Therefore, my r form will be 2 cos theta plus 3 sin theta from the question is equals to square root 13 cos theta minus 0.983 radian. So we shouldn't just stop here because the next part of the question says that hence. So the words hence means that we have to use this result that we get to solve this. So it's equals to 1. Okay, so I'm gonna write down here. Just now we have 2 cos theta plus 3 sin theta equals to 1. So from the r form that we solved just now, we know that this can be written as square root 13 cos theta minus 0.983 equals to 1. So now, if you're not familiar with radian, you can always change it into degree first, and then at the final answer, you change it back to the radian. So I will do it right now. I will prefer to do it in degree. So this is going to be 56.3 degree. Alright, but make sure you will remember to change it back to radian at the end. So I will get cos theta minus 56.3 degree is equals to 1 over square root of 13. So please notice that this is actually the first step of LARCA again. The second step, A, so the reference angle is cos inverse of 1 over square root of 13, which is 73.9 degree. The next one is range. So at first we have 0 to 360 degree, but because now it's theta minus 56.3 degree, so we're gonna change this to negative 56.3 degree and 303.7 degree. So the next step would be Q, quadrant. I would suggest to draw like this, so you will have negative 56.3 degree to 0 degree for the first one, and the next one is 0 degree to 303.7 degree. So this one will be negative like this. So I will darken this region, but I don't want. And here would be 303.7 degree. Here is the excess part that I don't want. So recall that from the question, we are actually looking for cos positive. So in quadrant 1 and quadrant 4, cosine will be positive, but there's nothing that we can do about this, so we're not going to choose any from that. We're going to choose from here, quadrant 1 and quadrant 4. So for our answer, we're going to write down theta minus 56.3 degree is going to be 73.9 degree, and also 360 degree minus 73.9 degree. So theta, you have to move this 56.3 to another side, so it's going to be 130.2 degree and 342.4 degree. But the question is asking in terms of radian, so you have to change it into radian. So it's gonna be 2.274 radian and also 5.976 radian. So now, by using R form, you are actually solving this equation.